Well, 4th of July's coming up.
Yes, it is. 4th of July rodeo, 4th of July parade, 4th of July, all kind of stuff happening in Makawao on Maui. It's a pretty fun time.
Fireworks.
Yeah, not too many fireworks this year. Cause they
you're not allowed to
everything,
shoot them up.
Yeah, they made everything illegal, but that doesn't usually stop people. They still shoot them, and then I don't know where they get them. But anyway, let's do some fun math.
Okay.
First thing we're going to do with this guy is warm up, which you've seen 100 times, but that's just building the add-ins, right? Using 2 hands, right?
Oh, yeah.
Yes, and then we will do some algebra. Okay, so let's start off with that. Start off with building add-ins. Okay, so we built all the add-ins, those 25, and then we built all 45 add-ins, right? We're building 10s, 11s, 12s, 13, 14, all the way down to 18, and we figured out that 18 only has one add-in, 9 and 9. Okay, and let's have a fun little exercise. Try to use 2 hands, and we need to go a little faster, but other than that, you're good. Okay, so you wanted to work on some fractions, doing reducing. Okay, and he admitted that he did not practice his multiplication while he was gone. Alright, gotta practice multiplication still too. Okay, but we'll save that for, you can do it at home. I'm not going to do it here. We'll do a little bit of practicing, but not much, just to see if you can do it. So let's do some quick stuff. What's 6 times 8? Not
40.
there. What?
40.
48? It's 4 times 7.
What is? Oh, 28.
Very good. 6 times 7. It's okay. Dude, if you knew everything, you wouldn't need to be here, would you?
No. Okay, so
count by 6s or count by 7s?
44.
Close.
43.
42. 43. Did you ever hear 43 on the multiplication tables ever? Did you ever hear 43? Anytime 43, anytime times what is what times what is 43? Nothing times nothing is 43. How about 9 times 6?
9 times 6. 54.
Very good. And one way to remember that, 1 less, and whatever it needs to add to 10. So you know what I mean? 1 less than 6 is 5, and 6 needs a 4 to be 10. 54. That's one way to do it. 7 times 9.
7 times 9.
So 1 less than 7 is 6, and 7 needs 3 to be 10. 63.
60. Oh, man.
Got it?
Yeah.
How about 9 times 9? 1 less than. There you go. That you know that one, but still, just doing the thing. 9 minus 1 is 8, right? And 9 needs 1 to be 10, so 81. So what would be 3 times 9?
That's 27.
Very good. See, last time you were here, you couldn't do 9s. You had no clue. You're like, I don't know. Okay. But we just practice, right? That's all it is. Okay, so, want to do some fractions instead of algebra?
Sure.
You want to do that reducing thing you were talking about?
Yep.
Okay. So let's do some of that. Let's put away blocks very quickly. I'll help you, and we'll do some fractions. Okay, we were cleaning up, but then I did some quizzing on this, and then we started doing some quick subtraction. So here, and he's seen it now, rather than doing, well actually we were doing addition, subtraction, all kind of quizzing, just, you know, getting used to the add-ins and what adds up. But that's why we do all the, what does 8 want to be?
It wants to be 10.
What's it need?
2.
Okay, so if I have 15 right there and I take away 8, you see? Ka-chunk. You see the 7?
Yeah.
Right? I was showing it to him. I have a different way of doing it, but I have to put it on the table. But he can see that 2 more, and so I got 2 plus 5 actually. So we turn it a subtraction problem, instead of counting backwards, we turn it into a small addition problem. See that? So if I had 15 and I wanted to take away 7, what does 7 want to be?
It wants to be 10.
What's it need?
3.
Alright, so boom. So instead I can't take it out of 5, so I just wind up with 8. See that? 5 and the 3, and you can actually see, we can put it on there if they're little kids, if they want to see it. But you can see the 5 and the 3. Okay, now if I have 15 and I take away 6, what does 6 want to be?
4. Well,
okay, you got ahead of yourself, but right, it wants 4 to be 10. Very good, very good. Okay, so I put it on there, boom, I get 9. Right? Because the 5 and the 4.
Yeah.
Okay, still easier than counting backwards. Alright, so we're just quizzing on these. What's 6 and 5?
6 6 and 5.
Mhm.
11.
Very good. What's 7 and 3?
10.
What's 7 and 5?
Yeah. 12.
Okay, calm down. Gotta relax. Gotta relax. You always get tense when we start doing this. Just relax. Because before this, how did you like math before this?
I didn't like it.
You didn't like it at all, right? Okay. So when he does math, even if we're just playing around, it's fine. But as soon as we start quizzing, you can actually see math anxiety spring up. Okay? And I see this with older kids too. They have math anxiety. They come here and it's easy, and then when they go take a test, they freak out because they take their all that old anxiety comes back. And the only way to beat that anxiety is to know it, right?
Mm-hmm.
So just practice, and then once you know it, it's easy because it's just variations on a thing. Okay, so how about if I had something like 16, and I'm going to take away 8. Can I take that 8 out of that 6?
No.
Right, so what do I have?
Yeah, take it away from there, and then you have 8.
Right. Right, because
There's 8.
8 needs the 2, 2 and the 6, 8. Right?
Mm-hmm.
Okay, so 8 and 8, 16. Okay, and then we can go higher. What if I had 23 minus 7? Just doing some thinking. Can I take the 7? Go ahead, go ahead.
16.
Very good. What did you do? Did you take the 7 out of one of the 10s and add 3?
Yeah.
There you go, right?
I took it away from the 10.
Right, so then you have a 6,
Yeah.
and there's one less 10 there.
Yeah.
Very good. Okay, and that's just practice, right? Look, no symbols, no pieces of paper, anything, right? We are just practicing with thinking about it, and then when we write it down, it's super easy. Okay, so now let's move on to some fractions after we, right? So just practicing with add-ins, just practice with multiplication, and now he wanted to practice reducing fractions. Okay. Okay, fractions. Multiple ways to do this. Very, very, very easy. Let's just start off with 1/2, right? Keep it simple. Even if it's below their skill level, it's good to start easy and work your way up as opposed to start hard and start dealing with problems. See that I have 1 to 2 there?
Mm-hmm.
Now how many?
Then you have 2 to 4.
All right, and can you see the relationship the same? Let's flip these guys over. Whatever, I have 1 to 1, 2.
To 4.
Right? I could look at this and I could say I have 1 to 2.
2 4.
Right? So 2/4 is the same thing as 1/2. The relationship is the same. So if I move out to over here and I have 4, how many on the bottom?
8.
4 to 8. But the relationship is still just 1 to 2, right?
Yeah.
We can look at that and see that it's still, if I look at this, 1/4 to 2/4. So we can call that 8. Right? And I need a line there. Let's put this box. Put that there. We'll call that our solidus. Right? Okay. See it?
Yep.
Okay. Simple. We need some symbols now. So you write it in your happy writing.
Okay. So
Okay, I'm going to say 7 to 14.
7 14. 7
Mm-hmm.
4. 7 to 4.
So 14.
14. Plus.
Okay, equals. Okay, what's that the same as?
As 7. So that's 14. 2 7s. Wait, no, not 2 7s. So it would have to be 2.
How are we going to get a 2 out of that? Tap your pen. Watch this.
Here.
See? Now, this is why you need multiplication. How many 7s is this?
2.
Ah, okay. So let's look at this. I'm going to move over by 7. See that?
Oh.
1, 2, 3, 4, 5, 6, 7. And down here I have 14. So what's the relationship?
The
Relationship is still... Look at it. Hey, for a second. Okay, so we just give him a simple, short problem set. 6 problems. Right? And he's already knocking them out. We know what the first one is what?
1/3.
Yep.
Look at the camera.
Yeah.
7 1 3.
Super easy, right?
4,
Oh.
7 1 and 2. So 4 times 5.
It's 20.
4 times 6.
There you go. See where the multiplication will make it fast and easy?
Yep.
Right?
Okay, so now 5. 1 over 4.
That's easy.
9. 1 over 2.
There you go.
Oh my god, that
It's okay.
oh, there was done. No, 8. That would be 1 over 3.
Done. Alright, so these are all small, easy ones. Now can we get harder?
Sure.
Right? Okay, see, now we have confidence. Sure, we can get harder. Right? Okay. That's called degree of difficulty. Right there. Okay, good job. I like it.
Oh yeah, I need to start learning.
Alright, so he looked at the problems and he went, oh, but still, they're still easy.
Yeah.
Do you see that each one of these, they're on similar multiplication tables, and you just have to figure out what the biggest number that'll go into each one of those is, using kid speak.
3.
Okay, so the biggest one that'll go in that one is 3, which is
That's
what?
1.
1, and how many 3's in 27?
There is, what can get closest to that? So 3 times 7 would be 21, but it can't
Keep
get
going.
there. So then, 7 times... Wait,
3 times.
Yeah,
3 times what?
3 times...
Because we found the common factor is 3 here.
3 times 9.
There you go. See, and if you knew your multiplication, it's super fast. You'd see it right away, right?
Yep.
That's what I mean. Practice your multiplication, man.
Yeah.
Practice, practice. It's got to practice. It makes
12.
all the math easier.
12.
Okay, so you think 12 is going to be the biggest number that'll go into both? You think you can get 12? Can you count by 12s to get to 54?
Okay, so... Sorry. So 12... 20, 22...
So
24,
12, 24, 36, 48,
and then...
60. Well, we missed it.
So it would have to be lower.
Have to be lower than 12. What's the next lowest thing from 12? Next biggest thing, that is. Or lowest, depending on how you're looking at it.
11.
6. Well, no, but I mean, it'll go into 12. 11 doesn't go into 12 evenly. What do you think?
Okay, so... okay.
Well, just do it. 11, no. 10, no. 9, no. 8, no. 7, no. 6.
Maybe.
Maybe. All right. How many 6s in 12?
How many 6s go into 12? 2 times 6 would be 12. So
Okay.
2, put a 1 on the top.
So put a 2 right there.
Put a magical 2. Oh wait.
Not a magical 2, but a 2. And make it nice. You're right. Oi. You. Nice symbols. 2.
Make the little thing right there.
Yeah, there you go.
Make a 2.
2 goes there. So what did we decide? We were dividing by 6, right?
Mm-hmm.
So now we got to figure out how many 6s go in there.
Yeah. So, and then, since that's a 2, 2 times, and then...
Wait. We're just finding out how many 6s are going in there. Because we got the common factor. Oh, okay. Well, we'll have to get the blocks out in a second. So in other words, 6 times what is 54?
6 times what equals 54?
Mm-hmm.
6 times 5 is 8.
6 times 8 is 48?
Oh. 9.
Yeah, there you go.
I was close.
Yep.
Okay.
So,
9.
9. So that reduces to 2 9s. So on top, I had 2 6s,
Yeah.
and on the bottom, I had 9 6s.
Oh, I was still thinking
Right?
about...
1, 2, 3, 4, 5, 6, 7,
I was
8,
still
9.
thinking multiplication at the point.
Right?
I was
But
thinking...
see what you're doing? That's why. You figured out that 6 was the biggest one that could go in there.
Yeah.
So to see my common factor, we should turn all these guys over so they're nice. See, even fuddling around like this takes too long. This is why you want to be able to grab multiple pieces. Alright. So, you see I have 2 to 9, but what I wrote there was the 2 big rectangles, 12 and 54. And what we just did was reduce and count the side. Right? So I see 2 there and 9 there. And that's why I had to figure out, well, if I know that 6 is going into this one, then 6 has to be going into that one, right?
Yeah.
So if I have 54 and one side is 6, the other side has to be... Yeah, 9, right? You see that?
Yeah, because the...
That's what I'm... And that's all it... What kind of problem are we doing?
Multiplication.
9 times 6 would be multiplication. I gave you the whole rectangle on one side. You need to give me the other side. That's called division.
Mm.
Right? 54 divided by 6 is 9. So see how multiplication and division go together? Right? Ooh, that's the pace I want that. Right? Okay, too late. Anyway, he was like, okay, yes. Alright. So now we've got to do the same thing on this problem. What do you think the common factor is going to be on this? 14 and 28.
7. I mean, that's 7.
That's good. 7. But what else? Could I go higher?
Yeah.
What do you think?
9.
9?
No.
9 going to 14?
No. Wait, I think 7.
Okay, we'll start with 7. Do that.
7.
How many 7s in 14?
2.
Okay, go. How many 7s in 28?
28, there is 3. I mean, not 3, 4.
There you go. Write it down.
4.
Oh, but are you done? 2 fourths?
2 4.
Can I keep going?
Yeah.
What?
That 2 turns into a 1.
Yeah, it doesn't turn into a 1. Let's see. That's
It's a 1.
It's a 1.
It's a 1.
Right? Because what we're doing is, and that's a
2.
Okay.
Half.
Right, it's a half. Can you see that 14 is half of 28? 2 times 14 is 28? Oh, right? Okay. But that's just being familiar with numbers. Okay, and we can do the rest of these exactly the same way. We're going to find the common factors, and we're going to reduce.
Okay, so
and do you see how the multiplication will make this super fast if you knew your multiplication?
Yep.
Especially when I got numbers like 56 and 24,
Yep.
right? Like this one's going to be easy, 15 and 25. What do you think that's going to be?
So if you had to put 15 into 25.
Can't do that.
Can't do that. So then you have to go lower.
Right.
So 10, no. Can't turn 10 into anything.
Yeah.
So 5.
Yep. So how many 5s in 15?
3.
There you go. How many 5s in 25?
5.
Done.
If it's.
See how easy it is? Okay, we'll turn off the camera and do these other two. Okay. But it's the same thing. Well, our common factor was 5.
Yeah.
Right? And we counted 5s out of this one, and we counted 5s out of that one. Okay. Okay, so we're shifting gears. Oh, and by the way, later on we can add fractions, right?
Yeah.
But we have to make them what before we can add them?
Same.
There you go. Excellent. Okay, so we're going to do all kinds of stuff with fractions.
10x, okay.
But wait. Now, I gave him a couple problems in algebra because we're out of time. Can you believe it? The hour's over. The hour went by. X squared, 10x, and 24. So I need x squared. Here's x squared. How many x do I need?
10.
Alright, fine. Take 10 the long way.
Okay.
Okay, and why is it that he's getting out 10x? 3,
10.
6, 8, 10. Okay, now I gotta put 24 in the corner. What do you think it's gonna be?
Okay, so I'm gonna use 2 sides. So 5 on one side.
Okay, well if I use 5, what would the other side have to be?
It has to be 5.
And that would be 25, right?
Yeah.
Okay, I want 24. Look at this.
6 on one side.
There you go.
And 4 on the other.
Okay, good. So the factors would be x plus
x squared.
Wait, just the factors, remember? X plus how many? Do we even need to get them out? Let's not even get them out. Take too long.
Okay, so
we know it's going to be x plus 6.
Yeah, 6 is.
And this is going to be x plus
4.
There you go. Write it out and draw it.
X square. I mean x.
I already told you the x square.
Yeah. X plus.
Cross 6.
Cross 6 equal.
Times. So put them in parentheses.
Yeah.
See, it's been a week since we've done this. Just like all the other ones on the page.
Yep.
Look at all the other ones.
And then another one, x.
The other factor.
4.
Put that in parentheses. And then draw a quick picture. And then the next one is x squared 10x. And
4.
Yep.
Do I have to draw that little thing?
No, heck no, it takes too long. Just like over here,
1,
just
2,
put the numbers
4,
in.
5, 6.
Right? And then how many goes there?
4 goes up.
24 goes in the corner. Right?
There you go.
Okay.
Now next. 16 this time. So now we gotta split it. 16, 8 on 8. So it could be 8.
Could be 8. Has to be 8.
Yeah, it has to be 8. How can we make 8? So cross here.
How many do you have now?
3, 4, 5, 6. I need 2 more. 8.
There you go. See? And again, the inspiration always comes suddenly. It's amazing. So what do we have for factors?
We have 2 across 8.
Yep, so I have x plus 8.
Yep.
We count that one first. X plus 8 across, and x plus 2 up. Draw a little picture, and you're out the door. Crewton Ramone's House of Math for more.